Welcome to our next unit, which is on coordinate geometry. We're going to be graphing and solving problems using geometric figures on a coordinate grid. And first thing we need to know to do any of that is we need to know the distance formula. This is how we're going to find the lengths of segments. Back in the first unit, we found lengths of segments by adding other segments together. Here, we're going to be using the relationship between horizontal and vertical position to find out how far apart they are. So notice this says x and x. We're going to be taking the difference in our x values of the endpoints of the coordinates, squaring that, and adding the difference in our y's squared. So our endpoints here we're going to label x1 and y1, and our other endpoint x2 and y2. Those numbers there are called subscripts. They don't have any numerical value, they're just part of the label. Now, where this formula comes from derives from the relationship that sides have in a right triangle. If we think of the horizontal distance, the difference between our x's, as just that horizontal distance there. The vertical distance is the difference in our y's. And the relationship between these three side lengths, the two acute legs of this right triangle and that diagonal hypotenuse, have the relationship a squared, if I label this a, this one b, and this one c. A squared plus b squared equals c squared. This is the Pythagorean theorem for right triangles, a, b, and c. So to find a, we just take the difference in our x's, x2 minus x1. To find our b, it's just the difference in our y's, y2 minus y1. And so if a squared plus b squared equals c squared, then to find what c is, we can take the square root of both sides. So the square root of a squared plus b squared is what c is equal to. So that's where that x squared minus x1 squared plus y2 minus y1 squared comes from. This is just a, this is just b, our horizontal and vertical distances. So let's see an example. So if I want to find the distance between 4, -6, and 0, 3, we'll start by plotting those. 1, 2, 3, 4, -1, 2, 3, 4, 5, 6. So 4 to the right and 6 down. There's our 4, -6. 0, 3, 0 left to right, 3 up, 1, 2, 3. There's our point 0, 3. And then we can connect those dots. So this segment is what we're finding the length of. We're finding the length or the distance or how far apart they are. Those are all different ways to ask that same question. So we're going to use our formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is our x, this is our y, this is our x, this is our y. It doesn't matter which one you call point 1 and which one you call point 2. Let me focus that real quick so you can see a little better. There we go. It doesn't matter which one's point 1 and which one's point 2. When you square a negative number, so I'll give you an example here. So if this is my point 2, 4 minus 0 is what we'll put in the parentheses there, plus -6 minus 3 squared, all under that square root sign. And then we can simplify. So 4 minus 0 is 4 squared plus -3 minus 3, or -6 minus 3 is -9 squared. If I had these switched, 0 minus 4 would be a -4, and 3 minus a -6 would be a +9. Whether you're squaring a 4 or squaring a -4, you're going to get a +16 either way. Or if you're squaring a 9 or squaring a -9, you're going to get a +81 either way. So the order that which one's your point 1, which one's your point 2 does not matter. Then we can add those two together, get the square root of 97. And then we can plug in the square root of 97 in your calculator. To get the square root sign, you can, or actually this is a simplified square root. If we want to get a decimal approximation, then we can plug it in our calculator. To get the square root sign in your calculator, you hit second and then the x squared button. Okay, that'll get you that little square root sign that's above the x squared. For now, I'll just leave it like that because I don't have my calculator on me. The second example, I'm going to do a little bit differently. I'm going to actually use the horizontal and vertical distances to show you a slightly simpler way, or a more expedient way, to find our distance. So start by plotting the points. -4, 2, -1, 2, 3, 4, 1, 2. And so there's our -4, 2. And 0, -8, 0, -1, 2, 3, 4, 5, 6, 7, 8. Connect our dots. Now, instead of writing out the formula as I did here, I'm going to draw the horizontal and vertical distances. So in this one, my horizontal distance, I can count 1, 2, 3, 4 units. And my vertical distance, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. To double check, the difference between 0 and -4, 0 and -4 are 4 units apart. And my y's, the difference between 2 and -8 is 10. They're 10 units apart. So my distance is the square root of, well, I already found my difference between my x's and my difference in my y's. I put them on my diagram, 4 squared plus 10 squared. So I can skip straight to that second step there after having labeled those on the diagram. So then 4 squared is 16, 10 squared is 100, and I get the square root of 116, oops, square root of 116 as my square root here. This can simplify further. 4 is a perfect square factor that goes into 116, so we could rewrite this as the square root of 4 times the square root of, and if you divide 116 by 4, you get 29. And then the square root of 4 is 2. 29 does not have any perfect square factors, nor is it a perfect square itself, so the square root of 29 stays the square root of 29, and that would be our simplified radical. Okay, so in this case, I'll just leave these as simplified radicals, but we can also plug these into our calculator to get a decimal approximation. Let me know if you have any questions in class, and we will move on from there. See you later.